that deals with the extractions of metals. So what is metallurgy? Metallurgy is the branch of science that deals with the extractions of metals. Okay, I mean, we got the metal from earth crust. They are ores. Okay, in the earth crust and in the molten form, in the rock form, or in the ionic form. So there are different forms. Okay, so what is metallurgy? Metallurgy is the branch of science that deals with the extractions of metals. How do we extract the metals? Like you have gold, platinum, silver, hydrogen, sodium, and different types of metals you have in your daily life. Okay, like iron. So how do we extract them? So there are different types of metals that exist in the earth crust. So we can simply say that the one kind or the metal exists in nature in two different forms. One is the native form. One is the native form. Native form means it exists in the purest state. Okay, so that is called native form. Native form. Other one is the combined state. Like for example, some low reactive metals like silver, Ag, gold, platinum, they generally exist in the native state. Sometimes copper also exists in combined state, also in the form of stable compound. But then other form in which the metal exists in nature is combined state. In combined state, what does metal do? Metal exists in the highly reactive metal exists in which form? They exist in combined state. Like for example, calcium exists in nature in the form of calcium carbonate. Lead exists in the form of PbS. Zinc exists in the form of zinc sulfide and zinc carbonate. Okay. And sodium exists in the form of sodium chloride. Aluminum exists in the form of Al2O3. Iron exists in the form of Fe2FeS and Fe2O3. There are different forms of metal that exist in this form of stable compounds, and that we called it combined state. So silver, gold, and platinum generally exist in the native state, but sometimes silver also exists in the form of AgS, silver sulfide. Copper exists in the form of copper sulfide, Cu2s. So there are different forms in which the metal exists in nature, and they are considered to be as combined state. So note it down this one, everyone. The branch of science that deals with the extractions of metal is called metallurgy. Note it fast. When you're done, please let me know. Done? Noted? Yes or no?
Yes.
Yes, you know her noted this one.
Yes, sir.
Gianna, you noted this one.
Yes, sir.
Okay. So the next, like combined state metal exists in different stable form. For example, Al2O3 dot 2H2O. This is a bauxite. This is an ore of aluminum. Next, if we move further here, okay. So metals means, if I'm talking that there are two differences, there are two different types of minerals. One mineral is that mineral in which from which the metals, if you extract the metal from it, it also contains. Like for example, if you want to extract the calcium, the calciums also contained in the normal soil that you walk on. Okay, but if you extract the calcium from calcium carbonate, it will be much effective for you and much easier and convenient for you. So it is not necessarily that only one like calcium carbonate is going to is the only source from which you can extract the calcium. No, it is not so. Calcium is present in the soil also. Calcium can be present in different substances. But the economical and convenient one is one from which the ore from which you can extract the metal economically conveniently, that is called minerals. Sorry, ores. So first of all, what I'm saying, what are ores and what is mineral? Mineral are those substance, those elements or compound that exist naturally in earth crust are called minerals. Those elements or compound that exist naturally in earth crust are called minerals. What we called it? Minerals. Okay, those elements or compound that exist naturally in earth crust are called minerals. What are ores? Those minerals from which metal can be extracted out easily and economically are called ores. So what are ores? Ores are those mineral, like for example, you have A, B, C, D, E. These are the five minerals. These are the five minerals. But if you want to extract the iron more economically, then B and C can give you the iron economically. The B and C can give you the iron economically. So we'll say that these two are ores, but B and C come from mineral. So it is a mineral as well as ore also. So those minerals from which metal can be extracted economically are called ores. And those from which we can't extract the metals are not considered to be as ores. They are just minerals. So all ores are mineral, but all minerals are not ores. All ores are mineral, but all minerals are not ores. Okay, understood? Yes or no? So first you have to memorize this one, and then you have to note it down. For example, if I'm taking another example like Al2O3 dot 2H2O, it is an ore of aluminium. Ore of aluminium. If you extract the metal from this one, this Al2O3, if you extract out metal from this Al2O3, it is easier and economical. It is easier and economical. But if you extract from Al2O3 dot 2H2O dot 2SiO2, if you extract it from here, it will be much more. We will simply say that it will be much more. Means if you extract it from here, it will be much more costlier, or it is not convenient. So this is a mineral only. This is a mineral only, but not an ore. But not an ore. So I'm going to ask you one by one that what is the difference between ore and mineral. Let me explain it one more time. That ores are those mineral. If you extract the metal from it will be economical. It will be easy, convenient. But those minerals, we cannot extract the metals economically. They are only minerals, but not an ore. So if I ask you that what are ores? Yes, you know how. What are ores? Noha, are you there?
Yes, sir.
What are ores?
If you extract,
Hmm?
if
Speak
you
a little bit
extract
louder.
from,
I can't hear you.
if you extract from mineral,
Yes, you Imad. What are ores? Ibad, what are ores? That Ibad is not responding. Okay. Yes, you, Gianna, what are ores?
So ores are minerals from which metals can be extracted economically or easily.
From which metals can be extracted economically and easily. Yes, you, Harshit, what are ores?
Sir, these are the minerals from which metals can be extracted easily or economically.
And what are minerals?
Sir, minerals actually.
What are minerals? Yes, you, Sumaya, what are minerals? You are muted.
Min Minerals are you cannot extract them economically.
No, no. Ores are also minerals. For example, Al2O3 is also a mineral. We can extract it.
You
All
can
ores are minerals.
extract it, but not economically.
No, it's not so. For example, if I'm saying here, like Al2O3, they both are ores. Sorry, they both are minerals. They both are minerals. But ore is only this one. This is not an ore. This is not an ore. So ores are those minerals from which metal can be extracted out economically. What are minerals? Those substance or element that exist naturally in earth crust are called minerals. Okay. So please first memorize the definition of this one, minerals and ores, and then you start writing. First, I will listen it from you, then you will start. Memorize it fast. What are minerals and what are ores? Done, everyone? Noted? Learn? Yes or
sir.
no? Okay. Yes, you. Sumaya. What are ores?
Ores are mineral which can be extracted easily and economically.
Yes, you know what are minerals?
The element whose compound that exists naturally from the earth crust.
That exist naturally in earth crust. Okay, start writing, everyone, please, fast. When you're done, please let me know. Done, noted. Done, everyone?
Yes, sir.
Okay, let's move further. Now, moving to the next point here is that all ores are mineral, but all minerals are not ores. What I'm saying that, everyone, that all ores are minerals, but all minerals are not ores. But one thing I want to ask you one thing, that we have decided the ores and how the metals are being extracted. So first of all, what we does, when we are just extracting the metals, we select the ore that selection of ores from the minerals, right? Which minerals are there from which you can extract the metal signal. The first step is selection of ores, selection of ores from minerals. From minerals, we will select the ores from the mineral. In the second step, what we does, when we select the ores, then what we does, we crush these ores. The second thing is crushing of ores. Crushing or hammering means we just convert it into pottery form. That is crushing of ores into powder. Then when we crush the ores, then what we do? We will extract the pure ores from it, and the sand impurities are being removed. So that is called removal of gangue. Removal of gangue what we called it impurities, or this is also called enrichment of ore. Enrichment of ores. And this is done by several steps, like we use magnetic separation for this, magnetic separation for iron ore, okay. Then we does uh, hydraulic washing or gravity separation. This is done for oxide ores, okay. And then fourth flotation method, fourth flotation method. This is done for sulfide ore. And the next one is fourth flotation method, sulfide ore. Okay, and leaching for bauxite, aluminum ore. For bauxite. Bauxite is an ore of aluminum. For aluminum ore. Aluminum ore. Especially Al2O3 dot 2H2. Okay, these are the various methods that we use for removing the impurities, like magnetic separation, gravity separation. Okay, fourth flotation method is generally used for sulfide ore, leaching for aluminum ore. And after this, we use, after crushing these ores, what we does actually. So when these impurities are being removed and these only we have pure types of ore, then we convert the sulfide ore. There are the three types, mainly four types of ore. Sulfide ore, like it is having PBS, AGS, Cu2S. So they are different means that is attached with sulfur, like Cu2S, Ag2S, okay, FES. These are sulfide ore. Okay, the second type of ore is carbonate ore. Carbonate ore that ends with carbonate group like CaCO3, like ZnCO3, okay, etc. Then another type of ores are oxide ore, like Al2O3 dot 2H2O, like Fe2O3, like Fe3O4, etc. And the last type of ores are halide ore. Halide ore. Halide ore means that is having halogen group. Halide means halogen group, having halogen group. Having halogen group. Halogen group means like fluorine, bromine, iodine, they are called halogen group. So if an element have NSC like this as chlorine group, so this is an halide ore. Like sodium fluoride. Okay. So calcium chloride, etc. So if this type of ores are there, then they are generally found uh, in halide. So mainly, if I'm talking about these two ores, the sulfide ores and carbonate ores, before we extract the metal from it, they are first converted into their oxide form. Like for example, if you have like you have CaCO3, calcium carbonate, so first you will convert it into calcium oxide. So both sulfide ore and carbonate ore are converted into their oxide form by different methods. And this is a step, what we called it, bringing the ore. The next step is bringing the ore, especially sulfide ore and carbonate ore, in oxide form. In oxide, we will bring them into oxide form. Why we are bringing? Because oxide form. Bringing the ore in oxide form. Okay, means what we have, if we have calcium carbonate, we'll convert it into calcium oxide first. If we have PBS, then we will convert it into PBO first before removing the metals. So the sulfide ore and carbonate ore are first converted into their oxide form. Why they are converted? Because it is easier to extract out metal in their oxide form rather than their carbonate and sulfide. Understood? It is easier to extract out metal from. Next is talking. Here is when we convert the sulfide ore and carbonate ore into their oxide form, then last step is that if we have calcium oxide, if we get PbO, if we have another metals. So when we get from their sulfide form, we just convert it into their oxide form. The next step is reduction, means removal of oxygen. Reduction means removal of oxygen or halogen. Okay, and last step is refining. So this is how we get the pure metal. So start writing this one on, and step by step we're going to discuss all of them. First we select the ore, then we crush the ore, then removal of gangue and impurities, and there are different methods by which you can enrich the ore, you can remove the impurities like magnetic separation, gravity separation, post flotation method, leaching, etc. Then when we get the pure ore, fresh ore without soil, without impurities, then we heat it or we bring the ore in their oxide form, and then we remove the oxygen and then finally refine it. Note it down fast. Are you writing, Sumaya? Yeah. Have you done? Noted? Yes. Is I'm audible to you?
Yes, sir.
Noted? This one?
Yes, sir.
Yes, you also, Sumaya and Harshit?
Yes.
Let's move on. Now, note it down, this one, fast. That halide ore, NaCl, CaCl2, oxide ore, is Al2, 3.2H2, sulfide ore, PBS, SADNS, Ag2S, carbonate ore, CaCO3 using carbon. Do it first. Done? Done? Okay, tell me then why it is easier to extract out metal in their oxide form rather than their carbonate and sulfide form. Can you tell me that why it is easier to extract out metal? Why it is easier to extract out metal in their oxide form rather than their carbonate and sulfide form? So note it down that it is easier to extract out metal in their oxide form rather than their carbonate and sulfide form.
Sir, because they're more reactive than the like pure
Yeah,
metal.
we can simply say, yeah, you can write it that why we are converting. First of all, the question comes that why we are converting into their oxide form. So we are converting it into their oxide form just because in order to extract out metal in their oxide form. Okay, because it is easier to extract out metal from oxide form rather than their carbonate form. For example, if you are going to extract out metal from calcium carbonate, it will be difficult if you extract out metal from oxide form. Understood? Note this question also. Done? Yes or no? Why are you not replying? Harshit, Nohan,
Done.
Jana, done?
Done, sir.
1 minute.
Okay. So what is calcination and roasting? So calcination is a process by which we convert carbonate ore into their oxide form. So in this process, since there is already oxygen present in the carbonate group CO3. So there is no external use of oxygen being required. So when we heat the carbonate ore in the absence of oxygen, they get converted into calcium oxide, or if it is calcium carbonate ore, and respective metals oxide we get. If it is zinc carbonate, we will get Zn. If it is calcium carbonate, we will get Zn. Sorry, CaO. So what are the advantages? It is like oxide form is more easily reducible than carbonate form. And if there is volatile, if some impurities are there which can volatile, which can melt at low temperature, because here we heat at 900-degree temperature. So if there is some volatile impurities present there, and if they means if they have melting point 200, 300, 400 degrees Celsius, then they can be easily melted out and can be separated. So volatile impurities also are also removed by this method. And what is roasting? Roasting is a process of in which we convert sulfide ore into their oxide form. So since if we have ZnS and we want to convert it into ZnO, so we require oxygen here because there is no oxygen. So we require external supply of oxygen. So roasting is done in the sufficient supply of oxygen or in the pair in the presence of oxygen. Here we get ZnO converted into oxide form. Okay, note it down fast. The calcination roasting, and then memorize it. I will listen it from you. Done?
No, sir.
Noha, are you writing? And Harshit, where have you gone?
So
Sir, I'm here.
Done. Noted roasting and calcination both.
Yes, sir.
Okay. So let's have some question over it. Yes. Okay, you just tell me. Harshit, are you there? Harshit,
Yes.
what's the answer for question number 11?
Uh, Sir, B.
Hmm?
B options of second and third.
Second and fourth.
No,
Yes,
sir,
you.
third.
Second and third. Yes, you. Jan. Tell me, which of the following metal exists in the native state? Hmm?
So, C.
C.
Yeah, second